Okay, so we have here our next topic, the Terzaghi's bearing capacity. This is for the shallow foundation. So Terzaghi's expanded Brandel's plastic failure theory to test the soil bearing capacity for shallow strip footing. So a wall footing length to width ratio over about 5 can be called a strip footing. So a foundation may be classified as a shallow foundation according to Terzaghi if the depth df is less than or equal to its width b, shown in the figure. So pag ito yung ating surface, meron tayong footing. Ito yung width nung ating footing. So, sinasabi natin na shallow foundation pag yung DF, ito yung depth ng ground surface mula sa bottom ng ating footing. Masasabi nating shallow foundation pag yung DF daw natin is less than yung ating B, yung width ng ating foundation. Okay? So according also to Terzaghi, he assumed that the weight of the soil above the base of the footing may be replaced by a uniform surcharge. So yung weight ng soil dito sa above nung ating footing may be replaced by this uniform surcharge. Yung Q times the unit weight times the DF. So, for ultimate soil bearing capacity, meron tayong equations for Terzaghi's bearing capacity in finding the Terzaghi's bearing capacity for general failure. So, ito yung ating Q-ult, yung ultimate bearing capacity natin, yung Q-ult. For the rectangular footing, we have here the equation. For circular, we have here the equation for the strip footing and for the square footing. Okay? So, yung mga NCC, yung mga notations na yan, dito yung mga notations na yan dito. Okay? So, ayaw mag-next. Ayun. Okay, so we also have here the local shear failure. This is for loose sand and soft clay. Unless specified in the problem, gagamitin natin yung general shear equation. Yun yung gagamitin natin. Unless specified na gamitin ninyo yung local shear failure. Okay? So, parehas actually yung ating equation. Pag mapapansin nyo, yung equation for the rectangular, circular, strip, and then the square, parehas lang doon siya sa ating general shear failure. Ang kaibahan lang dito, yung ating cohesion, ang gagamitin natin for local shear failure is C prime. So, modified na cohesion. And then, yung gagamitin natin for the NC, N sub C, N sub Q, and N sub Y is yung modified bearing capacity factors naman dito sa local shear failure, which is the N sub C prime, N sub Q prime, and N sub Y prime. So, yan lang yung kahibahan niya doon sa general shear failure. So, pag mapapansin nyo, parehas lang yung, almost the same lang yung equation natin. Okay? So, we have here, yung Q sub ult natin is our ultimate bearing capacity. So, ito yung hinahanap natin, yung ultimate bearing capacity natin. Yun yung capacity ng ating footing. Okay? So, yung C naman is the cohesion of soil. So, yung C natin is equal to QU over 2. So, yung QU natin dito, hindi yan yung Q ultimate Iba yung Q sub ult, iba yung Q sub U. Kasi yung Q sub U natin is our unconfined compressive strength. Okay? So, baka pag anuhin nyo yan na parehas. Iba yung Q sub ult kasi yan is the ultimate bearing capacity and iba yung Q sub U. That is the unconfined compressive strength. So, para makuha natin yung cohesion, pag hindi given sa problem, that is the Q sub U over 2. Okay? So, yung gamma natin is the unit weight of soil. And yung Q natin, this is actually yung value natin ng Q is the unit weight times the dF. Yung ating height nung ating from the surface, ground surface, papunta doon sa bottom nung ating footing. Yun yung dF natin. Okay? So, yan. Also, we have here the N sub C, N sub Q, and N sub Y. This is the bearing capacity factors that are non-dimensional and are only function of the soil friction angle. So, actually, this is given. So, may table tayo dyan para ma-identify natin yung N sub C, N sub Q, and N sub Y. Parehas dito sa ating modified bearing capacity factor, yung may prime. Yung N sub C prime, N sub Q prime, and N sub Y prime. Meron tayong table to identify kung ano yung value natin based on the frictional soil friction angle. Okay? So, ito, meron tayong table to identify these values. And then, yung B natin is the dimension ng ating foundation. Pag circular, yung B natin is equal to its diameter. Okay? So, yung C sub prime natin, that is equal to 2/3 of C. Yung C sub prime natin, 2/3 of the cohesion of the soil. And yung tangent phi prime natin is also equal to 2/3 nung tangent of phi natin, yung angle of friction. So, yan yung mga kailangan natin in solving for the ultimate bearing capacity of a given footing. Okay? So, pag meron na kayo, pag na-identify niyo yung mga notations natin, yung mga gamma, B, and Y prime, substitute lang natin dito sa equation and you can solve now for our ultimate bearing capacity. So, this is for the local shear failure. And the other one is for the general shear failure. Okay, so ito yung table natin in finding the bearing capacity factors. This is for the N sub C, N sub Q, and N sub Y. So, dito, pag meron tayong angle of internal friction na 30, for example, yung value natin ng N sub C is 37.16, yung N sub Q natin is 22.46, and yung N sub Y natin is 19.13. So, titingin lang kayo sa table na ito para ma-identify nyo yung values ng ating N sub C, N sub Q, and N sub Y. And also, pag meron din tayo for the modified bearing capacity factor, meron din tayong value here. So, pag in-identify ninyo yung ating angle of internal friction, meron siyang corresponding values of the modified bearing capacity factor. So, itong table na ito, itong dalawang table, is gagamitin natin to identify yung Terzaghi's bearing capacity factor natin. Okay? So, pag wala tayong table, pag hindi ina-identify, gagamit tayo ng formula to solve for the n sub q, n sub c, n sub y, and yung ating n sub c prime, n sub y prime, and n sub q prime. So in here, if we don't have a table, we will use this equation. Okay? So, according to Resner, yung Resner formula, NQ is equal to the tangent squared of 45 plus V over 2. So, E raised to pi tangent of angle. So, yung n sub c naman natin, meron din tayo dito. Yung n sub y natin, meron din tayo dito. And ito, dalawa yung n sub y natin. Gagamit tayo ng Vesic formula or the Mayer-Forf formula. So, either of the two, pwede ninyong gamitin. Okay? So, pag hindi specified sa problem, ang gagamitin natin is yung sa table. Okay? Pag hindi specified sa problem na yung gamitin natin is you need to solve n sub q prime using the Resner formula, gagamitin natin yung table. So, ito pa rin, yung table pa rin yung gagamitin natin. Okay? Kasi this formula is applicable only for the Terzaghi's bearing capacity factor. Hindi siya applicable doon sa ating modified. Wala tayong formula for the modified. Okay? So, pag walang given sa problem, ang gagamitin, the general shear failure. Yung equation natin sa general shear failure. Okay? So, meron din tayong factor of safety dito. So, yung factor of safety natin is actually the allowable bearing capacity multiplied by the ultimate bearing capacity. So, para makuha natin yung allowable bearing capacity natin, i-divide natin yung factor of safety doon sa ating ultimate bearing capacity. So, ito yung equation natin to solve for the allowable bearing capacity. And pag yung solve naman natin is yung factor of safety, just need to manipulate this equation. Okay? And then for the net allowable bearing capacity, yung net naman natin is equal to the net ultimate bearing capacity over yung ating factor of safety. So, pag sinabi nating net, ima-minus natin yung Q nung ating soil doon sa ating ultimate bearing capacity to solve for our allowable net bearing capacity, yung Q sub all net. Okay? So, iba yung allowable bearing capacity, iba yung net allowable bearing capacity. Okay? So, you just have to read all the meanings. Okay. So, in solving for the Terzaghi's bearing capacity, meron tayong tatlong case due to the effect of water. So, magkakaiba yung pag-solve natin in the ultimate bearing capacity due to the effect of water table. Okay? So, pag ginamit nyo yung general equation ng ating bearing to solve for our ultimate bearing capacity, merong effect yung water table natin. So, hindi nyo basta-bastang sa-substitute yung ating equation, values doon sa ating equation. So, you need to identify yung effect ng water table. So, meron tayong tatlong case. Yung una, pag ang water table daw natin is located at a distance above the bottom of the foundation. So, dito yung water table natin. Located siya above the bottom of our foundation. So, yung magnitude Q natin, yung magnitude natin, in the second term of the bearing capacity equation should be calculated as follows. So, ito yung magiging value natin for the magnitude Q doon sa ating second term pag meron tayong groundwater which is located at a distance above the bottom of the foundation. So, sa second term. So, pag titignan natin yung equation natin dito, ito yung first term natin. For example, dito sa rectangular footing, ito yung first term natin, ito yung second term natin. Okay? So, yung second term daw natin, yung Q natin dito, ito, yung Q natin dito, kasi ito yung first term natin, ito yung second term natin, ito yung third term natin. Yung Q natin dito sa second term is equal to this value. So, is equal to the unit weight times the dF minus D plus the unit weight prime, yung ating effective unit weight, yung gamma prime natin times the D. So, ito yung ipapalit ninyo. Ito, kasi 'di ba yung Q natin is the unit weight times dF lang. So, pag ang groundwater natin is located above the bottom of the foundation, yung Q natin papalitan natin ng etong equation. So, yung second term. So, ito. So, pag circular, yung second term natin, ito. Papalitan din natin ito ng equation na yon. Ito din. Pag strip and pag square. Ito siya. Okay? So, that is if our water table is located above the bottom of the foundation. Kasi 'di ba nga, yung Q natin, yung magnitude Q natin is equal to the unit weight times dF lang siya. Okay? So pag may effect ng water table, yung equation natin sa Q is mag-iiba. Pag yung ulitin ko, pag yung water table natin is located at the distance above, ito yung magiging equation natin for Q. Okay? So, yung gamma prime is equal to the effective unit weight or the submerged unit weight which is equal to the saturated unit weight minus unit weight of water. Ito, yung gamma prime. Also, the value of the gamma in the last term of the bearing capacity equation has to be replaced. So, hindi lang yung second term yung papalitan natin, yung Q. So, papalitan din natin yung last term of the bearing capacity equation by gamma prime. Okay? So, pag titignan natin yung last term, ito. So, papalitan natin ito imbes na gamma times dF, papalitan natin ng gamma times dF minus D plus gamma prime times yung ating, nakalimutan ko yung equation natin. Gamma prime times D. And then, doon sa ating third equation, ito naman. Sa third equation daw natin, ito, yung gamma natin dito, yung unit weight natin dito, papalitan natin siya ng unit weight prime. Okay? So, yan. Which is equal to the unit weight saturated minus the unit weight of water. Yung last term. So, pag dito sa circular footing, yung Q papalitan natin yung equation natin and yung gamma papalitan natin ng gamma prime. The same with the strip footing, yung third. Okay? That is if our groundwater is located above the bottom of our foundation. Meron din tayong second case. Yung case 2 natin, paano naman pag ang groundwater table natin is coincides with the bottom of the foundation? So, andito yung groundwater natin. So, yung magnitude Q natin is equal to gamma dF. Yun pa rin yung Q natin, yung gamma times dF. However, the unit weight of in the third term, yung unit weight natin in the third term, papalitan natin siya ng gamma prime. This is the saturated unit weight minus the unit weight of water. Okay? So, papalitan pa rin natin yung third term dito. Yung Q natin is equal to gamma times dF pa rin siya. Pag yung water table natin coincides with the bottom of the foundation. Okay? So, doon sa general shear equation pa rin tayo dito. And then, yung third case natin, pag yung groundwater table natin is below, meron tayong distance below the bottom of the foundation. So, andito yung groundwater table natin. Nasa baba nung ating bottom nung foundation. Yung Q natin is equal to gamma dF. Parehas pa rin. This is for the Q doon sa ating general Terzaghi's equation. Okay? Yung magnitude natin sa gamma, ito lang ang papalitan natin. Yung magnitude natin na gamma doon sa third term. Third term so sa third term pa rin tayo. So, etong third term pa rin tayo. So, yung magiging value daw natin dito, yung gamma daw natin dito, yung unit weight natin dyan, is equal to the gamma average. Yung average unit weight natin. And then, yung average unit weight natin, meron siyang equivalent equation. Meron tayo dito. If our D is less than or equal to B, so kailangan yung kunin yung ratio nito. Ratio. Compare yung D, tapos yung B natin. So, pag yung D, yung distance nung ating groundwater mula doon sa ating bottom foundation is less than nung B, yung Q gamma average natin, yung unit average natin, is equal to this equation. So, substitute nyo lang yung values ng B and D, and then yung gamma prime, which is the saturated unit weight minus unit weight of water. And yung gamma D is the dry unit weight of the soil. Okay? And pag yung D naman natin is greater than B, yung average natin, yung unit weight average natin is equal pa rin siya doon sa ating unit weight. Okay, parehas pa rin siya pag yung D natin is greater than B. So, yan yung tatlong case doon sa ating effect ng water table doon sa ating Terzaghi's equation. Okay? So, sa Terzaghi's equation natin, pag wala tayong water table, original na yung Terzaghi's equation, yun na yung gagamitin natin. Pero pag may water table tayo, kailangan natin i-identify yung mga effect ng ating water table doon sa ating equation in determining our ultimate bearing capacity. Okay? So, meron tayo ditong examples in solving for the bearing capacity using Terzaghi's bearing capacity. So, for the problem number 1, assuming we have a general shear failure, so sinabi nandito sa problem na ang failure natin is a general shear failure. So, we have to calculate the gross allowable load per unit area, yung Q all natin, that the continuous foundation as shown in the figure can carry using the Terzaghi's bearing capacity. Use table to determine the bearing capacity factor. So, in determining the NC, NY, N sub Y, and N sub Q, gagamitin daw natin yung table. Sabi dito, this is a continuous foundation. So, pag sinabing continuous foundation, per strip yung gamitin natin. Okay? So, gamitin natin yung equation for the strip footing. So, kukuha lang tayo ng strip na yung continuous footing natin. Tapos, yun yung i-analyze natin. Okay? So, yung unang gagawin natin is, sabi sa problem, we're going to use general shear failure equation. So, meron tayong ultimate bearing capacity. This is equivalent to this equation. Okay? So, given yung C natin, meron tayo dito sa problem. Wala tayong NC, N sub C. Wala tayong Q, wala tayong N sub Q. Given yung unit weight natin, at wala tayong N sub Y. So, para ma-solve yung N sub C, N sub Q, and N sub Y, tingin daw tayo doon sa table. With this given, yung angle of internal friction natin, which is 22 degrees, pag tumingin tayo sa table, pag kinuha natin yung 22 degrees, ang value natin ng N sub C is 20.27, N sub Q is 9.19, and yung N sub Y which is 5.09. So, ito na yung magiging value natin for these three factors. Okay? So, meron na tayong N sub C, meron na tayong N sub Q, meron na tayong N sub Y. Wala tayong Q. So, we need to solve for the value of Q. So, paano natin isolve yung Q? Wala tayong water table dito. So, yung Q natin is the unit weight times dF. So, given yung unit weight ng soil natin, which is 17.28, and given din yung dF natin, yung distance from the surface to the bottom of our footing, which is equivalent to 0.9. So, that is equal to 15.55 kilonewton per meter squared. Okay? And then, okay. So, meron na tayong Q. Okay, meron na lahat. Diba? So, we just need to substitute the values in our general shear failure formula na Q para makuha natin yung ating ultimate bearing capacity. So, yung C natin, which is 9.58, yung NC natin, 20.27, yung Q natin, 15.15, ito siya, yung ating NQ, ito yung NQ natin, plus 1/2, yung unit weight natin, 17.28, yung B natin is 1.2, and yung ating N sub Y is equal to 5.09. So, just need to calculate. Yung lalabas na ultimate bearing capacity natin is equal to 389.86 kilonewton per meter squared. So, ito yung ultimate bearing capacity natin. Pero hindi ito yung tinatanong dito sa ating problem. Ang tinatanong is the gross allowable load per unit area. So, allowable. So, to solve for the allowable bearing capacity, that is equal to the ultimate bearing capacity over the factor of safety. Yung factor of safety natin given, which is 2.8. This will result to 139.24 kilonewton meter squared. Okay? So, ito na yung magiging allowable Q natin. So, ito yung magiging sagot natin for problem number 1. Okay? So, let's have problem number 2. So, we have here sample problem number 2. So, we have a square footing. So, square daw yung footing natin. 1.2 by 1.2. So, ito yung given figure natin. The unit weight of soil is given as 17.25 and has a cohesion of 9.2. Angle of internal friction is 26 degrees. And we have to assume na yung ating failure is a general shear failure. Yung failure nung soil natin. We have to use the table to determine the bearing capacity factor. Okay. So, yung situation 1 natin, ito yung given problem natin. So, for situation 1, assuming we have no water table. So, wala tayong water table that exists below the foundation. So, wala tayong water table dito sa ating given diagram. We have to calculate our ultimate bearing capacity. We have to calculate our allowable bearing capacity if our factor of safety is equal to 2.5, and we also have to determine the gross allowable load that the footing can carry. Okay? So, pag wala tayong water table, so for situation 1, wala tayong water table. So, yung pinakaunang kukunin natin is the bearing capacity factor, yung N sub C, N sub Q, and N sub Y. So, meron tayong angle of internal friction which is 26. So, meron tayo ditong value ng N sub C, N sub Q, and N sub Y. Okay? So, for situation 1, pag wala daw tayong water table, so using our general shear failure formula, ito yung formula pag yung footing natin is a square. So, we have 1.3 C, N sub C plus Q, N sub Q plus 0.4 unit weight times B times N Y. Sabi dito, wala tayong water table. So, given yung C, nakuha na natin yung NC. Yung Q natin is the unit weight times the DF, yung distance from the surface mula doon sa bottom ng ating foundation. Yung NQ natin, nakuha din natin siya. 0.4 unit weight of soil is given. Yung B is also given, and yung NY is nakuha din natin siya sa table. So, pag walang water table, substitute nyo lang diretso yung ating values sa ating equation. So, pag sinubstitute nyo lahat yan, makukuha natin yung ultimate bearing capacity natin, which is equal to 650.6 kilonewton meter squared. So, ito yung ultimate bearing capacity natin. That is for letter A. For letter B, pag meron daw tayong factor of safety which is equal to 2.5, ano yung magiging allowable bearing capacity natin? So, allowable bearing capacity is equal to the ultimate bearing capacity over factor of safety. So, just substitute yung values natin, makukuha natin yung allowable bearing capacity natin, 260.24. And for the last question, we have to determine the gross allowable load that the footing can carry. So, paano makukuha yung allowable load? So, yung allowable load is equal to the bearing times the area. So, pag naalala nyo, yung capacity is equal to the, mali ito. Yung capacity natin is equal to the bearing, yung capacity natin, yung bearing capacity over the area. So, kasi ito yung bearing natin, yun yung ating, tawag ito, yan yung ating magiging stress. So, yan yung magiging failure nung ating footing. So, allowable load is equal to, since allowable yung kinukuha natin, allowable load, ang gagamitin natin is the allowable bearing capacity. So, Q allowable times the area. So, we have Q allowable 260.24 times yung area natin, yung footing natin is 1.21 by 1.2, that is square. So, 1.2 squared. So, yung makukuha natin na allowable load is equal to 374.75 kilonewton. So, yan yung magiging sagot natin for letter C. Okay? And then, for the situation 2, paano pag yung water table daw natin is coincides with the bottom of the footing? And yung magiging saturated unit weight natin is 18.6. So, andito yung groundwater table natin. Parehas pa rin yung kukunin natin, yung ultimate, yung allowable, and then yung gross allowable load. So, parehas pa rin yung equation natin. yung equation natin sa general shear failure doon sa ating square footing. Okay? This time, meron tayong groundwater table. So, meron tayong papalitan dito sa equation natin. Ano yung papalitan natin dito? Yung third term natin. Yung unit weight natin dito, papalitin natin ito ng unit weight prime or yung ating effective unit weight. So, ito yung papalitan natin. So, yung magiging equation natin dito, yung unit weight, magiging unit weight prime, that is equal to the saturated minus unit weight of water. Kasi meron nga tayong effect nung ground water. Okay? So, parehas pa rin yung NC, NQ, and NY natin. Kasi parehas pa rin yung angle of internal friction natin. Nakuha natin kanina yan. Yung C, meron din tayong C which is 9.2. Yung Q, yung Q natin is the unit weight times dF. Okay? Okay. Yun lang yung papalitan natin and the rest, given na yun. So, we just have to substitute yung values natin dito. So, meron tayong ultimate bearing capacity. Substitute natin yung values. Ito, yung magiging effective unit weight natin, which is the saturated unit weight, meron tayong 18.6 minus the unit weight of water, that is 9.81. Kaya meron tayong unit saturated minus unit weight of water dito. Times B, yung B natin is 1.2, times yung N sub Y, which is 9.84. Substituting the values, makukuha natin, ultimate bearing capacity natin is equal to 610.64 kilonewton per meter squared. And to solve for the allowable bearing capacity, that is equal to the ultimate bearing capacity over the factor of safety. Ang allowable bearing capacity natin is 244.26. And the same, yung sa ginawa natin doon sa situation 1, yung allowable load is the allowable bearing capacity times the area ng ating footing, which is 1.2 squared. So, meron tayong value for the allowable load. Ito yung allowable load na makikerry nung ating footing. This is equal to 351.73 kilo Newton. Okay? So, that is for the situation 2. Pag yung water table daw natin coincides with the bottom. Okay? So, the same problem, pero this time, yung water table daw natin is located 1.3 below the ground. Paano pag yung water table daw natin is located 1.3 below the ground? And our saturated unit weight is 18.6. So, kukunin pa rin natin ultimate bearing, the allowable, and the gross allowable load. So, parehas. Ito pa rin yung general shear failure natin. Ito pa rin siya. This time, yung papalitan natin dito, meron tayong papalitan dito. Yung ating unit weight dito sa ating third term. Yung unit weight daw natin dito is equal to the unit weight average. And then, dalawa yung equation natin sa pagkuha ng unit weight average. Pag yung D is greater than B and D is less than or equal to B. Magkaiba siya. Okay? So, we need to check yung D and B natin. So, yung D natin, sabi natin, located 1.3 below the ground surface. So, ito yung ground surface natin, ito yung groundwater natin, yung 1.3 ito. Tapos, yung ground surface mula sa bottom ng ating footing is 1. So, yung magiging D natin dito is equal to 0.3. 0.3, yung B natin is 1.2. So, magiging yung D is less than B. Okay? And if our D is less than B, we will use this equation to solve for the unit weight na average. So, given 1 over B, 1.2, yung dry unit weight. So, dry unit weight natin is 17.25. Ito yung dry unit weight natin. Kasi wala tayong water table dito sa taas. Plus, yung ating effective unit weight, yung gamma prime, that is 18.6 minus 19.81 multiplied by the B. Ito yun, 1.2 minus yung D, this is 0.3. So, makukuha natin unit weight average is equal to 20.97. Okay? So, substituting yung equation natin dito sa ating values natin dito sa equation, makukuha natin yung ultimate bearing capacity natin which is equal to 668.17 kilonewton meter squared. And for the allowable bearing capacity, ultimate bearing capacity over the factor of safety which is equivalent to 2.5. Yung value natin for the allowable bearing capacity is equal to 267.27. And for the allowable load, that is the allowable bearing capacity multiplied by the area. So, yung load natin, if our water table is located 1.3 below the ground surface, yung ating allowable is equal to 384.87 kilonewton. Okay? So, we have here the last example. So, for problem 3, a rectangular footing. So, rectangular yung footing natin, 1 meter by 1.4. So, yung width natin is 1 meter. And then, yung 1.4, pag ganun siya. So, pag ito yung footing natin. So, pag ganun yung 1.4 natin. We have to use the table to determine the bearing capacity factors. So, gagamit pa rin tayo ng table in determining the values of our bearing capacity factors. So, given this figure, yung groundwater table natin is located above noong ating footing. So, meron tayong effect ng groundwater. So, we need to solve for the ultimate bearing capacity, assuming local shear failure. And using factor of safety equal to 3, we also have to determine the allowable bearing capacity. And then for C, we have to determine the net allowable load on our footing. Net allowable load. Okay? So, to solve for the problem, identify muna natin kung anong equation yung gagamitin natin. Okay, so rectangular footing tayo. And then, assuming local shear failure, kaya yung equation natin is the equation doon sa local shear failure under rectangular footing which is equivalent to this equation. We have C prime and C prime times 1 plus 0.3 B over L plus Q times N Q prime plus 1 half unit weight times B N sub Y prime times 1 minus 0.2 B over L. So C prime. So, given yung C natin, masosolve natin yung C prime which is the 2/3 of C. So, yung 2/3 ng 15, yung C prime natin is 10 kPa. So, yung NC prime, NQ prime, and NY prime, kukunin daw natin siya sa table. So, pag yung angle of internal friction natin is 20, ang value natin for the modified bearing capacity factor is equal to this value. So, we have NC prime equivalent to 11.850. NQ prime, we have 3.880. Meron tayong NY prime equivalent to 1.120. Okay? So, meron tayong so, given din yung B natin and yung ating L. That is 1 by 1.4. So, unit weight meron tayong B, meron tayong B, meron tayong L. Ang isolve natin ito, yung Q. So, yung pag wala tayong water table, ang Q natin is unit weight times dF. But since in our problem, meron tayong groundwater table which is located above yung ating footing, yung magiging Q natin is equal to this equation. So, yung Q natin is equivalent to this equation. Saan na yun? Ito. Ito daw yung magiging Q natin. Unit weight times TF minus D plus unit weight prime times D. And then, yung third term natin, yung unit weight doon sa third term natin is equal to the saturated minus unit weight of water. So, papalitan natin ito. So, hindi lang basta-basta nyo i-substitute yung values ng unit weight dito. Meron tayong effect ng groundwater. So, yung unit weight natin dito is papalitan daw natin ng effective unit weight which is saturated minus unit weight ng water. Okay? So, to solve for the PO, yung Q, to solve for our Q, meron tayo, solve for the value of Q. So, meron tayong unit weight times H1 plus unit weight prime times H2. Yan yung ating QO. So, ito. Kung mapapansin nyo, yan. Yung equation na yan. So, we have the unit weight which is 18.1 times 1.2, yung height. Yung wala tayong effect ng water table. So, this is 1.2. Plus, yung ating unit weight prime which is 21.60 minus 9.81. Yan yung effective unit weight natin times H2. Yung H2 natin is yung D natin. So, andito yung D natin. Yan yung D natin. Yung DF natin, so ito. Kung mapapansin nyo, yung DF natin is from the bottom up to the surface. So, yung kaya 1. Wait lang. Kaya 1.2 ito, yung H1 natin, yung DF natin 2.6. Diba? 2.6. Tapos, yung D natin is 1.4. Okay? So, 1.2 yung ating value dito. And then, for the H2 natin, which is the D, yung 1.4. Kaya 1.4 ito. So, yan. Ito yung D natin from the groundwater mula sa bottom. Tapos, ito yung DF minus D. Since given yung surface mula sa groundwater yung 1.2, kaya 1.2 yung sinubstitute natin dito. Dito sa equation natin. Okay? So, yung magiging value natin ng Q is equal to 38.23 kilonewton per meter squared. So, yan yung magiging value natin dito sa Q. And then, for the value of the unit weight, meron tayong saturated minus unit weight of water. Okay? So, kompleto na yung ating values. Substitute na natin dito sa ating equation. Substitute natin yung sa equation natin yung values natin. So, C prime 10 and C prime 11.18. 1 plus 0.3 of P is 1 and 1.4 yung L natin. plus yung Q natin is 38.23, yan yung solve natin kanina, times the NQ prime, nakuha sa table, plus 1/2, the saturated unit weight is equal to 21.60, minus the unit weight of water, 9.81, times the B, which is 1 meter, times the NY prime, 1.12, times 1 minus 0.2 B of over length. So, pag sinubstitute natin yan, pag sinolve natin yan, pag kinalculate natin yan, ang magiging ultimate bearing capacity natin is equal to 297.88 kilonewton per meter square. Okay? So, yung pangalawang hinahanap natin is the allowable bearing capacity if our factor of safety is 3. So, you just have to equate yung equation natin, ultimate bearing over factor of safety. This is equal to 99.29 kilonewton per meter squared. And for the allowable load that the footing can carry, yung net allowable load natin is equal to the allowable bearing capacity natin, yung net times the area. So, paano natin makukuha yung net allowable bearing capacity natin? That is equal to Q ultimate minus Q over Fs. So, iba ito kasi yung nakuha natin dito is the allowable bearing capacity. Ang hinahanap natin dito is the net allowable load. So, dapat yung sa taas natin is the allowable bearing capacity, yung net. Okay? So, yung net natin is Q alt minus Q over Fs times area. So, yung ultimate bearing capacity natin is 297.88 minus yung Q natin is 38.23 over Fs times the area, which is 1 times 1.4. Kaya yung net allowable load natin is equal to 121.17 kilo Newton. So, that's the answer for the problem number 3.